All right, class, so we just finished our quiz over simplifying radicals. So now we're going to go over our first set of special right triangles. And our first set of special right triangles, or our first triangle, is the 45, 45, 90 triangle. Let's go ahead and look at the warm-up first, though, kind of recapping what we did on the quiz. Let's go ahead and multiply these radicals. So 6 times 2 gives us 12. And then square root of 3 times square root of 3 gives us the square root of 9. Some of us may go directly to 3 instead, which is fine, right? Because the square root of 9 is 3, and 12 times 3 is 36, right? Exactly what we've been doing. All right, and then on the next one, we'll multiply both numerator and denominator by square root of 3. The top becomes 6 square root of 3. If we need to, we'll make that a 9. But again, some of us can go directly to 3 because we know that when we multiply a square root to itself, we're just squaring it. All right, and then we ask ourselves, is there anything else we can do here? Yes, we can reduce the 6 and the 3. All right, 6 and the 3 become 2. So 2 square root of 3. All right, let's look at number 3. 3 is done the exact same way, so we'll multiply the numerator and denominator by the square root of 3. The numerator is now 15 times the square root of 3. The bottom, again, those of us that need to go to 9 will go to 9. What is the square root of 9? 3. And then can we do anything else? Yes, this here will reduce to 5 square root of 3. Okay, so now let's go ahead and jump into our 45, 45, 90 triangles. So our 45, 45, 90 triangles, these are triangles whose degrees are 45 degrees, 45 degrees, and 90 degrees. That's why it's called the 45, 45, 90 triangle. Now, a 45, 45, 90 triangle is actually just half of a square, right? Because what do we know about a square? We know all the sides are equal and all the angles are 90, all right? This is something we should know from elementary. All the angles are 90, all the sides are equal. Well, what's half of 90? What would be 90 divided by 2? It would be 45, right? So this is a 45, 45, 90 triangle when we split a square directly in half. Now, the reason I'm pointing that out is you will have some problem talking about a square being cut diagonally. That means that they have made a 45, 45, 90 triangle because this here is your diagonal, in case we don't know what a diagonal is. Okay, so the 45, 45, 90 triangle does have a special relationship. The legs, the sides across your 45s, these are always the same. Because this is actually what type of triangle? Is this isosceles? Is this scalene or equilateral? It would be an isosceles, right? Because two sides are the same. So this is your isosceles right triangle, your isosceles right triangle. And it has it up here. It is an isosceles triangle. So those two sides are going to be the same. Now, if you look very closely, your hypotenuse is going to be whatever your leg is times the square root of 2. So if your leg happened to be 4, the other leg will also be what? 4, because these have to be the same. And then the hypotenuse, the one across your 90 degrees, is whatever your leg is times the square root of 2. So if this is 4, this is 4, this is 4 square root of 2. Okay, let's try another one. So let's suppose our leg is 5. This is 5. This is 5. This one is going to be what? 5 square root of 2. So this is beneficial so that when you're doing Pythagorean theorem, if you know it's a 45, 45, 90, you don't have to sit there and do all the work with Pythagorean theorem. You can say that the ratio or the relationship of the sides here of the 45, 45, 90 triangle is that the legs are the same. So if this is 7, this is 7, the hypotenuse will be 7 square root of 2. And that's it. You found all the sides. There is no work needed when it's a 45, 45, 90 triangle and all you're given is a side, because then you can easily find the hypotenuse. Now, there will be some cases where there is work, right? But here I'm giving you the basic gist of the ratio of this 45, 45, 90 triangle. So if your hypotenuse is 10 square root of 2, what do you think your legs are? They're going to be 10. Good. All right, let's just try one more. If your hypotenuse is, let's say, 11 square root of 2, what are your legs? 11. Good. All right, so just different ones. All right, let's look at the first one. So always fill in your angles. All right, we're going to fill in our angles, 45, 45, 90. If this leg is 6, this leg is also 6. So your hypotenuse is going to be your leg, whatever your leg is, in this case it's 6, times the square root of 2. And you found all your sides. All right, let's do this one. Actually, let's go to C real quick. All right, fill in your angles. Fill in your angles because it's going to help some of you, especially if we struggled with an isosceles triangle and we still don't know that relationship. This can be a challenge. So this is why I recommend that you always take the retest if you fail the test, because you do have to still know the material. All right, so across this 45 we have 9, so this leg should also be 9. So your hypotenuse is whatever your leg is times the square root of 2. All right, so whatever your leg is, right? So in this case, if we know this is a 45, 45, 90 triangle, this is 45 and this is 45. So if your leg is 9 square root of 2, you write that down because that's your leg, and you multiply this by square root of 2. So just like this one, 9 square root of 2. This is 9 square root of 2, 9 square root of 2. So 9 square root of 2, you still have to attach that square root of 2. All right, now from here, you already know what to do. So now we're going back to what we did with the simplifying radicals, right? So what can we multiply? The 2's, good. So we're going to do 9 square root of 4. What is the square root of 4? 2, good. So 9 times 2 is 18. So 18 is our x. All right, I'm going to go ahead and give you a moment to try practice 1. Okay, so now looking at practice 1. So again, 45, 45, 90. We have 45, 45. If this is 4, this one is also 4, good. So x is going to be, we should have 4 square root of 2, good. All right, look at the next one. I know those are 45 because my sides are the same. So remember, when your sides are the same, your angles are also the same. And the only angle they can be is 45 because a triangle has to add up to 180. All right, so we have 5, 5. So what's your hypotenuse going to be? 5 square root of 2. That's it. All right, 45, 45. If this is 9 square root of 2, this one's also what? 7 square root of 2. The other one's also 7 square root of 2. For the hypotenuse, you write down whatever your leg is. You write it down. And regardless, you have to multiply it by square root of 2. Now again, hopefully we're seeing that, again, anytime you multiply square root to itself, you're squaring it. So this is just 7 times 2. So here x is 14. That's our x. All right. Okay, let's go ahead and go on to the next page. So on the next page, so this one says you can also work backward using the Pythagorean theorem to find the lengths of the legs. So we're not going to do Pythagorean, well, you can do Pythagorean theorem, but you could also just work backward. If your hypotenuse is 5 square root of 2, well, what was your leg? Remember, your ratio is the leg, the leg, the leg, square root of 2. So what's in place? What's representing our leg here? The 5 is, right? Because the square root of 2 is what we have to add. This is representing the L. So that means x is 5, x is 5. That's all it is. Now on B is different. Because on B, we need to know that 12 was derived by multiplying your leg times the square root of 2. Well, let's undo this. If this is x times the square root of 2, what do I have to do to figure out what I multiply to get 12? What's the opposite of multiplying? Dividing, good. So we'll multiply both sides by square root of 2. So now we have, and we'll just go from here. I have x equals 12 divided by square root of 2, right? We can't have that square root at the bottom, so what do we have to do? Multiply, good. Square root of 2, square root of 2. The bottom just becomes 2. The top I'm going to rewrite as 12 square root of 2. Is there anything else we can do here? Yes, the 12 and the 2 can be reduced. So what's 12 divided by 2? 6. And that's your x. This is 6 square root of 2, 6 square root of 2. And if you want to check your answer, well, you can just go backward, right? You can say, if these are 45. So if this is 6 square root of 2 and this is 6 square root of 2, to get that 12, we should have multiplied that by square root of 2. And what's square root of 2 times square root of 2? 2, and that gives us 12, which is exactly what we got. So this was me just checking. All right, I'm going to give you guys a moment to try practice 2. All right, practice 2. So if we're looking for our legs, and I have 17 square root of 2, mind you, that's leg square root of 2. What was our leg? Should be 17. Okay, next one. This is the whole number. Anytime you have that whole number on the hypotenuse, that's your cue that we're going to have to divide. All right, so we have, I'm going to do L. L square root of 2 gave me 18. Let's divide both sides by square root of 2. All right, so our leg is going to be 18 divided by square root of 2, so we just have to simplify it now. All right, so we should have multiplied by square root of 2. L is 18 square root of 2 over 2. And what's 18 divided by 2? 9, good. So L is 9 square root of 2. So that's what we should have had here. Our x should have been 9 square root of 2. Any patterns y'all see here? Because what I'm seeing is that if I have a whole number here, more than likely, I'm going to have a square root here. If I have a square root on my legs, my hypotenuse is going to be a whole number. Okay, that's given that we have square root of 2. Now, if you have a different square root, we can have square roots on all sides. But if it's just square root of 2, our legs will more than likely just be a whole number, and our hypotenuse will have that square root of 2 next to it. All right. A kite string is 300 feet long from the kite to the ground. The string makes a 45-degree angle with the ground. About how high off the ground is the kite? Round to the nearest foot. I'm going to have you guys leave it as a square root. Okay, so wants to know how high is it off the ground. So there's your 45-degree angle. It's right there. So your other 45-degree angle has to be on the other end. The kite string is 300 feet long. The string is. This is how long the string is. They want to know how high is the kite off the ground. So what do you think we're going to do? Was I given the hypotenuse or the leg? The hypotenuse. Now remember, the hypotenuse is your leg times the square root of 2. So what do I have to do to both sides? Divide by the square root of 2. Our leg is 300 divided by the square root of 2, which we can't have a square root at the bottom. Okay, so then from here, I have 300 square root of 2 over 2. Can I reduce 302? We can. The leg is 150 times the square root of 2. All right. The next one's talking about an official baseball diamond. Some of us may not watch baseball, so let me go ahead and help you draw this real quick. The official baseball diamond is a 90 by 90 square. And I know that doesn't look like a square. I apologize. You have home plate. Sorry. You have home plate. You have first base, second base, and you have third base. All right, I'm going to give you guys a moment to try practice 3. All right, I read an official baseball diamond is 90 by 90. Home plate, first base, and second base form an isosceles right triangle. Home plate to first base to second base, form an isosceles right triangle. So this is a 45, 45, 90 triangle. Find the distance that the second baseman, which is here, must throw the ball to catch it at home plate. So here. So we want to know this side. So if I was to draw this away from the full picture, you have a 45, 45, 90 triangle. The sides are 90. So what would be the distance that we're looking for? Correct, it would be 90 square root of 2. And this one I did ask you guys to leave it in radical form, so just leave it there. All right, one last page. When you're ready, we'll go to the next page. All right, so what if we don't have a square root of 2? So this is the one that could have square roots everywhere. Okay, so what you always want to do is make sure that cannot be reduced from the beginning. Will anything go into 6? No. Okay, so then let's do this 8 square root of 6 is x times the square root of 2, right? So this is how they got this. Whatever this was, they multiplied it by the square root of 2, and that's how they got 8 square root of 6. All right, because if you look at your diagram, that's what it is. Let me just draw the diagram up here. Some of us may need to see the diagram. So x square root of 2. All right, so then, and this is always the hypotenuse, it's across the 90. So just like the other problems, we're going to divide by square root of 2. So this is where simplifying those square roots is going to come into play. We have 8 square root of 6 over the square root of 2. We can go different ways here. Let's go ahead and multiply by square root of 2, though, because that's the steps most of us should have ingrained by now. All right, and then we have x equals 8 times the square root of 1. Should be 12. The bottom just becomes what? 2, good. All right, 8 divided by 2 is 4. Can we do anything else? Yes, you can break down the 12. So this is 4, square root of 4, square root of 3. What's the square root of 4? 4 times 2. What does that get us? 8 square root of 3, good. And those would be our legs. So remember I said, we're kind of talking about those patterns. And I said, if it's not the square root of 2, you could have square roots. You could have square roots on all the sides. Now, one thing we could have also done, I kind of talked about this on our last lesson, or our last day on our last classwork, was that if you have 8 square root of 6 over square root of 2, you could reduce your square roots. That would be 8 square root of 3 over square root of 1. What's the square root of 1? 1, correct. So if I have 8 square root of 3 divided by 1, don't you still have 8 square root of 3? All right, so, and again, these are the steps we practice, so this is what we should all be able to do, but if y'all notice that, yes, y'all could do that. All right, and let's look at the next one. This time with our legs have a square root, but it's not a 2. All right, so on this one, we know this one should also be 6 square root of 6, but to get the x, we're going to take our leg, and we're going to multiply it by the square root of 2, because no matter what, whatever your leg is, you write it down when you're looking for the hypotenuse, you write it down, and you have to multiply it by the square root of 2, because that's what we do for the hypotenuse. All right, what's 6 times 2? 12. Can you break down 12? Yes, so that should be 6 square root of 4 square root of 3. Which one reduces? The 4, good. So what, 6 times 2? 12, so 12 square root of 3 should be my hypotenuse. That one does not have a shortcut, okay? That one you have to be able to do all that. All right, let me go ahead and give you a few minutes to do the last practice. All right, let's check it. So for the hypotenuse, we could have done 20 square root of 6 divided by the square root of 2. You could have reduced there if you wanted, so I'll do that method here in a minute. Let's go to multiply by square root of 2 for those of us that did that. Can you reduce 20 over 2? Yes. That should be 10 square root of 12. Can we reduce the 12 by 4 and 3? Which one reduces? The 4. 10 times 2 is, it should be 20 square root of 3. So our legs should be 20 square root of 3. But reminder that you could also do that other method. If you have 20 square root of 6 divided by the square root of 2, you can reduce the 6 and the 2. That would be 20 square root of 3 over square root of 1. What times itself gives us 1? 1, right? The square root of 1 is 1. All right, and then that would also give us 20 square root of 3. And then the last one. On the last one, we have, this is my leg, so across the other 45, we should have the same thing because it's an isosceles. To get the hypotenuse, you take your leg and you have to multiply it by the square root of 2. What is 3 times 2? 6. Will anything go into 6? No, so that one's done. Yes, that one was a lot shorter than the example, right? The example had, this example up here had a couple of more steps. It just depends. So just because one problem showed a lot of work or had more steps than the other, doesn't necessarily mean that you did it incorrectly. It just depends what square root we're dealing with, okay? All right, just a reminder on the homework, you're only gonna do the side that talks about the 45, 45, 90 triangles.